Problem 5.3. So here we have some data from the past 500 working days, and that data consists of the number of cars sold per day. And so we've gone through and we've looked at the different numbers of cars that we could sell in a day, and it ranges in this case from 0 to 11. And then we've counted up the frequency of the number of cars sold per day. So for example, we know that on 142 of our 500 days, we sold 2 cars. So we've got this historical data, we've turned it into a frequency distribution, and what we want to do now is have a look at it in terms of a probability distribution, and then once we've got the probability distribution, we can think about its characteristics. So that means finding the mean, or what we call an expected number, and it's a probability distribution, as well as the standard deviation. Okay, so how do we do this? Well, it's quite common to have some past data as we do in this case. And while when we've represented it in the original table, we've got the number of cars sold per day from 0 to 11, and then we've got the frequency. To create a probability distribution, what we've got to do is work out the probability of each outcome. Now keep in mind here that we're interested in the number of cars sold per day, so we're going to let that be x, our random variable, and you should also notice that our random variable x in this case is discrete. It ranges from 0 to 11, and we have a finite list of possible outcomes. So we have a discrete random variable, and that means that we're creating a discrete probability distribution. And to do that, we know that for each of our outcomes x, we need to know the corresponding probability. Now in the question, we're just given the frequency information, so we need to be able to turn the frequency data into probabilities for each outcome. Now that's a fairly straightforward task. To go from a frequency to a probability, all we need to do is divide each frequency by the overall total. Now we could have added up all our frequencies to see that the total number of days was 500. Of course, we were already told that in the question. So we just need to go through and calculate the probability of each outcome. Now, for example, for an outcome of 0 cars sold per day, which happened 40 out of the 500 days, if we convert that to a probability, 40 divided by 500 will be 0.08. So that's our first corresponding probability to the outcome of 0. We look to the next row. When we sell 1 car per day, well, that happened 100 out of the last 500 days. 100 divided by 500 gives us a probability of 0.2. And so you can continue down through the rows, looking at each frequency, dividing by the total of 500, and that will give you your probability column. So once you have your outcomes and their corresponding probabilities, you have your probability distribution constructed using frequency. Now, here, this question is a little bit bigger than what we would normally do by hand, and so in fact I did set it up in an Excel spreadsheet, but we have a question a little bit later where it's a bit smaller and we work through it by hand. So just keep in mind that in terms of, say, exam questions, if I asked you to do one of these by hand, it would be a little bit smaller. And certainly in something like Excel, we can add up all those probabilities in our probability column and just check that they add up to 1, which is always property we would expect in a probability distribution. So discrete random variable, discrete probability distribution, we have the outcomes x that represent the number of cars sold per day, and then we have the corresponding frequency turned into probabilities, which gives us our probability column. So outcomes, corresponding probabilities, we've got our probability distribution. Now, parts B and C, we're asked to work out the expected value of this distribution as well as the standard deviation. Now, you'll see that in my next column of working, I've gone through and I'm looking at each x, so each outcome, multiplied by its corresponding probability. Now I need to do that for every row, and then I can add them up. So for example, in that second column that I'm creating, where I'm multiplying x by the probability of x, which is how we create the weighted average for our expected value, 0 cars sold per day times the probability of 0.08 gives us 0. Go to the next row. 1 outcome times its corresponding probability of 0.2. Multiply those together, you get 0.2. Next one. 2 cars sold per day multiplied by the corresponding probability of 0.284 gives us a total of 0.568. So you work your way down through the rows, looking at each x, your outcomes, and multiplying them by their corresponding probability. When you have all of those components, you can add them together, and again, in something like Excel, that's quite easy. Use the sum function, and we end up with 3.056. So that tells me, on average, I expect to sell 3.056 cars per day. So that's what the probability distribution is telling me. And if I have a look back to even just my frequency information, I see that the most frequently occurring number of cars is 2, 1 is second, 3 is third, but certainly there are more values above 2 than below. So getting an expected value of around 3 certainly seems quite reasonable. So that is my average for this probability distribution. I then need to look at a measure of variation, and we've been asked in part C to have a look at the standard deviation. Now, to do standard deviation, I have to in fact work out variance first, and just like when we do the expected value and we have to weight the outcome, when we do a variance, we have to weight our squared deviations. So the formula looks a little bit like variance for a normal data set, except we're using the probability. Now I can break my variance formula up into parts. So I can start off by getting the deviations. So that means each x, each outcome, subtract the expected value. Now I've already worked out the expected value, it's 3.056. So I'm going to go through my number of cars sold per day, so my x's, and I'm going to subtract 3.056 from each. So we see in the first row of that column, 0 minus 3.056 gives us negative 3.056. If I go to my next row, my x is 1, I'm going to subtract my expected value, so 1 minus 3.056 gives me negative 2.056. 2 cars sold per day, subtract the expected value, gives me negative 1.056. So I work my way down through the rows, each x subtract the expected value. So that's the deviation. For each of those values, I need to square them, and so I've created another column to do the squaring. Again, very easy to do in Excel. So, for example, if I have negative 3.056 and I multiply it by itself, so I square it, I come up with 9.339. Next deviation, negative 2.056. Square it, so multiply it by itself, 4.227. Work your way down through the rows. Once again, you're getting each of those deviations and you're squaring them, and of course they should therefore all be positive. The final step is to get all of those squared deviations and weight them according to their probability. So for each of those values, starting with the 9.339, we need to multiply it by its corresponding probability. So we would have 9.339 multiplied by 0.08 gives us 0.747. Next row, we've got a squared deviation of 4.227 multiply by its corresponding probability of 0.2 gives me 0.845. So work your way through the rows once again. If you're doing this in Excel, set up some formulas, copy and paste down. Once we've got all of those squared deviations weighted by their probabilities, we need to add them together, and that will give us our variance. So I use the sum function in Excel. I add all those values in the last column, and I come up with a variance of 6.068864. So you can round that off to do decimal places if you wanted to quote the variance. Of course, variance isn't as easy to work with, so I can take the square root and I come up with 2.46 rounded to two decimal places. So I can now tell you that this is my probability distribution of the number of cars sold, the corresponding probabilities. On average, I expect to sell 3.056 cars per day, and that varies on average by 2.46 cars per day. So that gives me an idea of generally what kind of variation I'm going to see above and below my expected value. Okay, so that's 5.3, and that's an example of a general discrete probability distribution. Of course, it was a little bit larger than what we'd normally do by hand, so we have used Excel, but we get to practice the smaller one later.